Hello guys, welcome back to Horus Labs YouTube channel, and in today's episode we're going to be looking at structs and how you can basically utilize them. We're going to be looking at understanding the method syntax and a whole lot more. If this is your first time joining the series, I would once again advise you go back and check all the episodes before coming back so you can basically flow with this particular episode. And without further ado, let's get started. So structs are very much similar to tuples, which we looked at I think in episode 3 or 4 of this particular series, right? And I think the biggest limitation you'd probably have working with tuples, right, is the fact that members of a tuple are not named, but they contain different data types, right, unlike an array. And your structs are just very similar to tuples, right, but they excel over tuples in that they help you achieve more organization, since you can name members of like the struct data type. So this is basically what we're going to be looking at today. We're going to be understanding how to use structs within like our Cairo program or our Cairo contract, right? And so to probably like understand this better, let's dive into like VS Code and get our hands dirty. Now, back in our VS Code, and the first thing we're probably going to do as always is we're going to come here and update our README. So this is going to be BC7, and we're going to just call it structs. All right, so I'm going to create, let's initialize a new scar project, and I'm going to, let's just call this struct, right? I'll probably just update this later. So we want it to be a simple Cairo test. All right, so we have a new folder here named struct. I'm just going to sorry, not that. I'm just going to come here and rename it. Let's call this BAC7 as we've always done, right? Okay, so we're going to head into BAC7, and here's the lib.cairo. So we're not going to be writing inside lib.cairo today because I want us to like segment our codes into like two different files, right? So I'm going to create those two files. So the first file is going to be let's just call this structs. Let's call this structs.cairo. And the second file we're going to, let's call it methods.cairo. All right, so that's going to help better with the organization. So as always, we're going to just come here and mod structs and mod methods. Okay, so once we have that, we can now dive into our structs and start making magic. All right, so one more thing, I just want to cd into like BAC7 so we don't get errors when we try to like run or compile or do all those stuff we usually do, right? So let's just cd into that. All right, so the first thing you want to do when creating a struct, right, which is one of the important things we learned in like the previous chapter when we looked at ownerships, right, is we want to inherit this drop macro. Because last time, if you watched the previous episode, right, when we tried creating our structs without the drop macro, right, the compiler was shouting at us, and we looked at what the drop macro is and why you should always like derive it on structs, right? So if you probably do not understand most of this, I would advise you to go back to like check the previous chapter. So we're going to create a struct. Let's call this struct user, and this struct is going to have, let's start with a username, right? And this username is going to be like a byte array, and we want to get probably like the user's age, and this can just be like, let's say uint 8, and any other important information we might need. So username, age. Okay, let's just get the user's gender, and this can also be like we can make this a simple byte array too. Okay, so that's as much as we need for like our user struct. Now, how do we instantiate struct? So what we just did here was define this user struct, right? But when you want to create a new struct item, something I prefer to call instantiation, right? How do you do that? So what we're going to do is we're going to create our main function. All right, now we're going to instantiate a new struct, a new user. So let's call this user Darlington. Sorry, I don't know what's wrong with my hands and key. All right, let's call this user Darlington. and Darlington is going to be is user struct. Now you instantiate a struct by calling like the struct name and passing in like a key pair, like a key value pair, right? Where you pass in the username and the value of the username, the age, the value of the age, the gender, and the value of the gender, something like this. So we're going to start with the username. So I prefer to go with OX Darlington. Then we're going to pass in an age. So we're going to pass in gender, and as always, the byte array. And yeah, so this is essentially how you instantiate a new struct item or create a new struct item. So just doing this, we've created a new struct item called Darlington, right? We could actually create more. So let's say we want to create another struct item. Let's call this user Chioma. So Chioma is a struct, right, of user. So we want the username to be OX Chioma, and the age is going to be let's say 19, and the gender is going to be female. So we just created another struct item. This is essentially how you create struct items. Now if you want to access any item within the struct, you do that using like a dot notation. So if you want to get, okay, let's say I want to get Darlington's username, right? How I can simply just do that is I'm going to say Darlington dot username, and doing that alone we should be able to get like Darlington's username. And you can do that for Darlington's age, Darlington's gender, do that for Chioma's age, username and gender, and so on and so forth, right? So that's basically how you create a new struct create a new struct item, right? And you can see how that differentiates from a tuple, because we have the ability to name our struct items, and those that kinds of like gives us more organization and a better way to like use and play around with this. So let's head back into our Cairo book and see what else we are missing. All right, so back in our Cairo book, we already created a new struct. We already learned about how to initialize new structs, right? So the next thing we're going to look into is how using shorthands. So that's what essentially this means, right? Is let's heading back into our VS Code, right? So let's say I have a function, or let's create a function. So I'm going to call this function create user. Now this function takes in, let's say, a username and username which is of type byte array, takes in an age which should be of uint 8, and takes in like a gender which is also like a byte array. All right, now this we can also make this return like the user struct, right? And so essentially, let's say we want to create this new user and return it every time we call create user. So we could simply just do something like user and just pass in username, passing age, passing gender. Now we want that to return the user, so we're not like going to close it with like the semicolon at the end. So you can see here we didn't bother doing this is also valid, but we didn't really do that, right? Because since this and this has the same it has the same variable name, essentially when you do something like this, the compiler knows like that it's a shorthand for passing in like this username for the username struct member. And so let's make our code a little bit more organized. So we can just simply make a call to like a create user, and I'm going to pass in the username I want, in this case OX Darlington, and I'm going to pass in the age I want, 22, and the gender I want, which is male. And I am going to do this again and call create user, and I'm going to pass in OX Chioma, and I'm going to pass in the age 19, and I'm going to pass in the gender, in this case, which is female. And that's just basically how you can use shorthands for like your struct items. And yeah, we could actually do something from like, let's say I want to access Darlington's age, right? I could simply still do Darlington.age, and I can I can essentially print that using, let's try to print that using this print line command, and I'm going to say Darlington's age is, and I'm just going to print Darlington age. All right, so if we try to run this, right, so I'm going to just do scab Cairo run. So you can see it says Darlington's age is 22, essentially printing like the age item within like the struct. Alright, so heading back again into our Cairo book, we already looked at how you can use the field in its shorthand, creating instances from other instances with struct update syntax. Okay, so heading back into our VS Code, you can actually create or update like a particular, like create a new struct basically from an existing struct item. So let's say I want to create another new user. So in this case, I don't know, let's call this new user Emeka. All right, and we want Emeka to have, okay, Emeka can have a different username. So let's say OX Emeka, right? But we want Emeka is same age as Darlington, so we will just want to use Darlington's age here, right? And Emeka is the same gender too as Darlington, so we can also do Darlington's gender. Okay, so we are having an error. What is this error? Missing member username. Oh, right, sorry. So this is, remember I said you pass it in as a key value pair, right? So this is also meant to, this is going to be like a gender. Oh, sorry, this is going to be age rather, and this is going to be username. Okay, now we have our error cleared out. So as you can see, we are creating this new struct item called Emeka, but while reusing Darlington's age and Darlington's gender. Now if you try to print, let's say you're trying to print okay, let's just do a new let's Emeka's age, right? And we want to get Emeka dot age. You're going to see it's going to be same as Darlington's age, right? So we're just going to rename this to Emeka's age and Emeka. So when we run this, so I'm just going to clear this and scab Cairo run. Now when we run this, right, you're going to see we get Emeka's age is 22. So essentially that's how you can reuse, like create a new struct item, right, from like an existing struct item. You could also do something else. So let's say there's also another shorthand you could actually utilize to do this. So as you can see in this case, all I needed to change was the Emeka's username, right? But I am reusing like Darlington's age and Darlington's gender. I could do something like this. Darlington. All right, so essentially when you do something like this, your compiler understands it as, oh right, so I want to change Darlington's username, but I want to change Darlington's username, right, but I want to reuse his age and his gender. And so when we do this and we try to run scab Cairo run again, you're going to see we're still going to get Emeka's age same as Darlington's age. So you run that and you can see what we get returned, right? Is Emeka's age is 22. So that's an important shortcut you could actually use. But something to keep in mind when using this utilizing the shortcuts, right? For example, in the cases of byte array, which is not copyable, when you do something like this, essentially you're just using the equal to sign. So you're moving that value or that variable, whatever it is, right, into this variable you are creating. So for example, if here let's say somewhere here, for example, we're using Darlington.gender, right, you're going to see an error here right now because saying variable was previously moved, and that's because remember what we talked about in the previous episode. The byte array does not implement like the copy traits, right? And so when you do this, you're essentially moving this byte array here into like this particular variable, and thus you can't exactly reuse it here. So that's something else you need to actually keep in mind. All right, so we're just going to go back to the initial implementation we had. Okay, so let's head back into the Cairo book, see if there's any other thing we're missing. Back in the Cairo book. All right, so we already looked at this, and yeah, that's it. We already looked at how you can use the dot syntax to move order to like utilize the remaining or existing elements within like a particular struct you instantiated. And yeah, so let's take the quiz before we head into like the next sub chapter. All right, it says determine whether the program will pass the compiler. If it passes, write the expected output of the program. All right, so we have the struct called point, and it derives the copy and drop trait. All right, if you something else to mention, right, is if you if you noticed, let's go back to our code editor, right, you'll notice we didn't generate the copy trait here, and that's because, like I said, the copy trait is not implemented for byte arrays. So if you tried, for example, like implementing the copy trait here, you get this error that says invalid copy trait implementation. Trait has no implementation in context byte arrays. So that's something else you need to keep in mind. So if you're going to use the copy trait on a struct, ensure it doesn't contain elements like byte arrays. All right, so back into our Cairo book, let's like continue with our quiz. So we have this struct, right, and it derives the copy and the drop trait, and we have the main function, and we are creating like a new struct item from the point trait, initializing x to 1, y to 2. So then we get e.x, add 1 to it. Okay, so 1 plus 1 equals 2. Then we initialize b, we pass y becomes 1, and okay, and we just pass in the value of e, the remaining value of e, in this case x. So e dot x plus is equal to 1, and now we are asked to print b dot x. So what's going to be the value of b dot x? All right, so let's look at it. So in here we created this new struct item, then we updated the value of x to be 1. So in this case the value of x now is now 2. So in here where we have point here, y is still 1, but the value of x in this case, which was we got from here, right, has been updated. So the value of e becomes 2. Now this is not really going to count at this point since we're trying to print the value of b. So this is just going to end up mutating this value and has no business with this particular one. So this is going to compile, and the input is going to be 1 2. So 1 for y, and sorry, we are just printing b dot x, so that is going to be just 1 plus 1 2. All right, so let's submit and move on. So determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So once again, we are creating a point struct, and we create our first struct item 1 2. Then we create a new variable passing p.x 1 2. Then we mutate it, and we are printing p.x p.y. So when we did this, right, we created new variables that we passed the value of p.x and p.y into. So whatever mutation we do here should not affect the initial value of p. So p.x and p.y should still be printed out as 1 and 2. So this will compile, and the values should be 1 and 2. All right, so as you can see, we got the 2 questions correctly. That's great. I believe you also like you got it from your end, so that's if you attempted it before I did. All right, so next up we're going to be looking into the next sub chapter where we write like an example program using structs. Alright, so now into the next sub chapter, we're going to be writing an example program that uses structs, right? And it's going to be like a simple program for like calculating like the area of a rectangle. And so let's dive into our VS Code and probably just get our hands dirty. Okay, so back into our VS Code now. I don't really like all these errors I've been seeing, right? And we probably left it, we probably ignored it in like the previous episodes. But something you probably need to note, right, is you could always like ignore these errors by just adding an underscore to the variables. So that's because the variables were not exactly used, right? So you could just add underscores to ignore them. Okay, so what we want to do now is we want to write a simple program that calculates essentially the area of a rectangle. All right, so I'm going to do one more thing. Let's create a new file. I'm just going to call this inside here, let's call this example.cairo. all right, so just so because I noticed someone complained the whole stuff we had with writing everything into one file was a bit confusing to follow, so I think this would be easier. All right, so example.cairo, as always, we want to add it to our lib.cairo, so I'm just going to let me so this does not print to the terminal, and I'm going to add more examples because that's the file we're working with right now. So mod example, not examples. All right, so back into our example.cairo file, let's create a struct. So now I'm going to derive copy. I'm going to derive both copy and drop because there's not going to be byte array in the struct. And let's call the struct rectangle. And rectangle is going to have like a width. Let's just make this a uint 16, and the height, let's also make this a uint 16. All right, so we're going to create our main function, and within our main function we want to create a new struct item, which is a rectangle. So let's say we want our rectangle to be equal to, all right, rectangle, and we want to initialize the width. Let's say we want the width to be 30 and we want the height to be 40. Okay, and what I'm going to do, just to make things cleaner, is I'm going to create another function. Let's call this function calculate area, and this function is going to basically take in a rectangle. Let's call this rect, which is going to be of type rectangle. Okay, and all we want to do is we're going to just multiply the area of the rectangle is basically the length times the breadth. So we're going to just say rect dot width, right, times rect dot height, which are essentially the members of this rectangle struct. Okay, so once we do that, right, we want to, something I forgot to do, right, is we want this to return a value. So this is going to be uint 16 since they are both uint 16s, right? And okay, so we're going to come into the main function and we're going to simply say let area be equal to calculate area, and we're going to just pass in our rectangle. All right, so let's try to print let's say the width, the area is, and our area is going to be area. So let's see what value we're going to get. Let's see if that works well. So I'm just going to clear this, and once again scab Cairo run. All right, so you can see we get returned the area, right, which is basically the width times the height, 30 times 40, which is 1200. So that's essentially how you probably like want to use structs, right? So as you can see, we initialize the struct. So we create like we create the struct, we define the struct, right? Then we create an instance of the struct. Then essentially we use it like within this function. All right, so let's head back into our Cairo book and see if like there's any other thing we need to cover. Okay, so in here they just walked through how you would have done it with tuple and how structs makes it a lot better. So you could read up on that, but we don't really have time to go through that. Like sub chapter. All right, so the next thing I want us to look into, right, is conversion of custom types. So essentially you can actually, I think we looked into how you could use the into and the try into methods, right, when we looked at data types. That should have been episode 3 or 4, right, where we looked into data types. We looked at how you could actually use how Cairo provides, the Cairo core library provides you with the into and the try into method you could use for like from converting from one data type to another. You could actually implement a custom into, right, for your custom struct, because for example this is not like supported by default like from the core library, right? So if for some reasons you want like to be able to call into to perform like some whatever calculations or whatever it is, right, you can actually do that for both into and try into. And so let's try that. Let's head back into our code editor and let's play around with that. All right, so we want to implement like the into method first. Afterwards we're going to try implementing the try into method. And what we want to essentially do with the into method, right, is we want it to convert a square into like a rectangle. So once passing a square, right, and it should convert that square into rectangle. So let's do that. So essentially we're going to do that is an implementation. So I don't think we've had the chance to look into traits and implementation. I believe we should do that like in probably the next 2 or 3 episodes, right? We're going to be looking into traits and implementation, but in this particular sub chapter we're going to also be playing around with it when we get into like the methods sub chapter. All right, so we're going to be creating an implementation. Let's call this implementation we want it to be convert a square into a rectangle, right? And we want it to, now when you are writing an implementation is usually done on a particular trait. Now this into trait is gotten from like the core library, and we are writing another implementation for that particular trait, right? So this into method is going to take in 2 things, which are like essentially the types. Now we want to convert a square into a rectangle, so we're going to create a struct. Let's create a struct, and let's just, as we've always done, let's just derive copy and drop, copy drop, and this struct is going to be called square. And like a square usually just has one side, and basically it has what's it called, all the sides of a square equal, right? So we can just use one side to represent it, and that length can also be like a UN 16, right? So what we want to do is we want to pass in a square and get returned like a rectangle. All right, so when we do something like this, we say we want to write a custom implementation for the into traits. So you can see we're getting an error. If you hover over the error, it says not all trait items are implemented, missing into. Now this is an implementation contained or defined within the into trait, and if we're going to write an implementation for that into trait, we have to implement that particular function or that method that's defined, right? So we have to implement the into function, and what we want the into function to do in this case, we want it to take in a self of type square, right? And we want it to return a rectangle. So it takes in a square and it returns a rectangle. All right, so what we essentially want to do, right, like we said, a square has all sides equal, so but our rectangle has 2 sides, the width and the height. So if you are converting a square into a rectangle, the width is going to be same as the length, so in this case self.length, right? And the height is going to also be self.length. And now with this simple implementation, you've written like you've basically written an implementation for like the into trait for converting squares into rectangle. Now let's try using this and see how this would look like. So I'm going to just come down here and let's just say into trait implementation for custom types, and I'm going to initialize a square, which is going to be of type square, right? And it's going to be a square which takes in just the length. Let's say the length is 20. All right, and we want to convert that square to a rectangle. So I'm just going to call this rectangle 2, since we already have a rectangle, and this particular one is going to be of type rectangle. And what I'm going to do is I'm going to simply call the into method on the square, and that should essentially convert our square into a rectangle, and we should be able to at this point get the width and the height on our rectangle. Now you notice I passed in the type, which we probably did not do here, right? And that's because when you're using the into trait, you want to kind of like specify what type you want it to convert into. For example, even though you're going to get this error that says type annotations needed, fail to infer, so in this case we're telling the compiler, oh yeah, what we want to convert into, right, is like a rectangle, and that's essentially what we're doing. So we can do something like we want to print, let's say we want to print let's just do the same line. All right, we want to print the width of the rectangle is, and we can just simply say rectangle 2 dot width. Now that's going to be same as the length we passed in 20. All right, so we're just going to clear and scarp Cairo run. Alright, so as you can see, it says the width of the rectangle is 20, which was essentially what we did. Now the way we did for the into trait, we can also do something similar, right, for the try into trait. So for the try into trait, let's do the opposite, right? Let's try to convert a rectangle into a square. So we try to convert a rectangle into a square. Forgive my typos. Alright, so we're trying this time around, we're doing this, writing an implementation for the try into trait. And remember, we're converting a rectangle, so it takes in a rectangle and it returns a square. Now, one of the major differences between the into and the try into, right, is that the try into returns the option type, right? So what we're essentially going to do is we want to return the option type for like our implementation. All right, so we want the try into is going to take in itself this time, which is going to be of type rectangle, and we want to return an option. So this time around we can't just return the square directly, so it expects to return like an option, so which is what we're going to return. And we're going to just simply do something like if so how you know that it's a square is essentially how you would exactly know that it's a square, right, is that all the sides are equal. So we can do something like we want, let's just, so if self.height, right, is equal to like self.width, what we want to do, we want to return let's return an option of sum, and it's essentially going to take in instantiate like a new square item, right, and the length is going to just be width. It can be the height, anything, right, since like all the sides are equal. And so that should return, so if self.height is equal to self.width, we want to like convert it into like the square struct type, right, and else we can just simply return an option none. Alright, so that should work perfectly for us. So if we want to use that, right, I'm going to just come here, comment again, try into traits implementation for custom types. So we want to, let's just try to use the rectangle too, right? So we want to create a new square. Let's call the square 2. And as always, right, we need to specify the data type we want to convert into, and we can just do something like rectangle 2 dot try into dot unwrap. Remember, it returns an option, so we have to unwrap that. Alright, so we're getting an error, unexpected argument type, expected struct, example square. Oh, okay, our trying to is converting rectangle into square. Okay, and this is returning, let's return the square. Let me see, let's remove this first to know where our issue is coming from. Alright, so essentially that was where our issue was coming from, yeah, because our implementation looks correct. Okay, so this is just what we did, right? We could just simply do the same thing. Let's try to print once again, and we're going to print the length of our square is, and we can just simply print square 2 dot length. All right, now if we run that again, scap Cairo run, we're going to get the length of our square. So I think I have a typo there. So you can see the length of our square is 20. So I have a typo. This is supposed to be square, not square. All right. So yeah, so that's essentially how you can write custom implementations of the into and the try into, like for custom data types like structs. All right. So let's head back into our Cairo book and finish up with like our quiz. Okay, so now we're back into the Cairo book, and we've done our implementations for into and try into. So let's just take our quiz so we can head into our next sub chapter. Okay, so determine whether the program will pass the compiler. If it passes, write the expected output of the program. So we have the structs, rectangle, width, height. Okay, so we have this function perimeter, which takes in a rectangle and performs some operation for calculating perimeter and returns the value. All right, so we have the main function, let rectangle equals this. We instantiate a new struct item, then let p equals perimeter rectangle, and then we print this rectangle dot width, rectangle dot height, and p. This is going to fail. This is not going to compile, and that is because, remember, for structs, if you want structs in this, for example, looking into here, right, we instantiated the rectangle struct item, then we pass it into the perimeter function. So essentially this variable has been moved into the perimeter function, so you can access it here. If you want to access it here, then this struct item has to derive copy too, so this will not compile. All right, so we're going to submit that. Heading into the next question, to determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So let p equals point x5 y 10. This is not the right way to like the structural struct items, so this too would not compile. All right, so let's see. Okay, so this is correct. So this does not implement copy, of course, and this is also correct. All right, so we are going to head into our last sub chapter where we look into like the method syntax. Alright, so the last subchapter we're going to be looking at on the structs is the method syntax. Now methods are very similar to function, right? You create them or declare them with the function keyword, and they can take in parameters, they can return values, they can execute code logics, and so on and so forth. Some key things to note about methods though is most times you'd have to define or implement them right within the context of like a struct or an enum, and their first parameter is always self. Something else also is like when you're calling a method, you usually want to call it on like an instantiation of like the struct itself, right? And it's usually like called with the dot notation. So I think the best way to probably do this, as always, right, is just dive into our code editor, play around with methods, and try to like understand it. Alright, so back in our code editor, and we're going to move into the methods.cairo. And within methods.cairo, we're going to initialize another struct. So derive copy drop, and we want to implement the rectangle struct again. And width, let's call the width. The width is going to be UN 16. The height is going to be UN 16. Alright, so we want to define methods on the rectangle struct. Now, methods are usually defined using an implementation, and like I explained earlier, an implementation is defined on a trait. So it means we have to specify a trait, right? Let's call this the rectangle trait. And what this is essentially going to do is going to specify it's meant to contain or specify the interfaces or like the functions every single function or method, right, that is callable like on the rectangle struct, right? So let's start with a very simple method. So an area method, and this is going to something that I don't know if I mentioned earlier, right, is that most times methods are going to take the first argument as self, and self can either be taken as a snapshot or as a reference. But since our area does not exactly like perform any mutation, but just like just calculations, multiplication, and returning the value, we're going to take it as like a snapshot. So if you don't understand difference in snapshots and references, you might want to like go back to reference the previous video. Okay, so we want to return u in 16, and this is essentially how you specify your trait. So you can specify multiple methods that is callable on this rectangle struct, but we're going to start with this. So now we want to write the implementation for our rectangle trait, and we're going to say implementation of rectangle. Let's call this rectangle implementation of rectangle trait, right? And this is going to specify the code logic for like the area function. So this takes in like a snapshot of the rectangle struct. It returns like a u in 16. Alright, so as always, what this is going to do is it's going to multiply the width and the height of our rectangle and just simply return it. But remember what we did in the previous like episode once again, right? When you are performing calculations on snapshots, you might want to like desnap it later on, right? Because if you hover over this, you can see we get an error that says like core integer in 16 is not the same as like the snapshot of it. So we want to desnap this, so we're just simply going to add the star operator, right, to desnap it. So yeah, this star in the middle represents multiplication, but this star appended to the cell values are basically the snap operators, so just keep that in mind. Alright, so we just created our own very first method. Now let's try to use it. So we're going to create a function, and it's just going to be similar to what we did last time. So this main function, which we're going to instantiate our first rectangle, and rectangle takes in a width 20, a height 30. All right, so we want to, once again, we're going to do what we did earlier. We're going to okay, let's just not do that then, because we already have a method. So I want to create a function earlier, but we'll probably just be repeating ourselves multiple times. So we can simply get the area by just saying let area be equal to rectangle.area. And that's all you need to do. That's all you need to do. So now if you try to print the value of our area, so the area is area. Now I don't want, since we're printing to the terminal, I don't want the stuff from the print statement from example to show up. So I'm going to go into lib.cairo, and I'm going to just comment that out, so the compiler does not have access to it. All right, so we just did this, right? We created our own method and we just used it on the rectangle trait. So let's see if it returns our area. So we're going to clear and scarp Cairo run. So you can see gets the area is 600. So that's essentially how you want to create what's it called, a method, right? And you can actually recall we passed it in as a snapshot, right? We can actually also pass it in as a reference. So but most times when we want to pass by reference, right, is when like the function which the value is being moved into like mutates it, right? So for example, let's write down that function. Let's call this function scale, and this is going to take a reference to self rectangle, and all it's going to do, right? So anytime you implement a function within implementation, you have to specify it within the trait too. So when you just specify scale, takes in the reference self, right, and takes in the rectangle. All right, so the scale function, and what I'm probably just going to do is I'm going to just okay, let's say we want the scale to take in a factor, and the factor is also a unit 16. So we're going to pass this in here to factor a unit 16. Okay. Alright, so what we want to do in our scale, right, is we want to say the self dot width, and we want to multiply it by the factor, and do the same for like the height, and multiply it by the factor. So when we call scale, essentially this is what scale is going to do. So we can do something similar. So we're going to say let's let's just say let scale be equal to, it doesn't return anything essentially, so we can just do rectangle dot scale. Alright, so having an error here, it says wrong number of okay, so we need to pass in the factor. So we want to scale by 2. Let's scale it by 2. Alright, still have an error here. Ref argument must be me. Yeah, right. So if this is going to, well, we're going to pass it by red, so it means this has to be immutable value. Alright, so now let's try to, if we try to print let's try to print the new width is, so we scaled it, so essentially the new width is going to be 20 times 2, which is 40. So we're going to say rectangle dot width, that's going to be the new width. Now if we clear this and Cairo run again, so we are going to get 40, which is 20 times 2, so our new width is 40. So that's essentially how you can pass values into like your methods, right, by reference. So let's head back into our Cairo book and see if like there's anything we are missing out on. Alright, so back into our Cairo book, we've learned to define methods, and yeah, so the generate traits, we missed out on this. Now it can begin to get very annoying if you always have to like explicitly define traits every time you want to write method implementations, right? So for this, Cairo provides like the generate traits macro. So let's head back into our VS Code, and we can actually do something like take out the traits. So we don't want to, this is like extra code logic, extra garbage, right? We can do something like tell Cairo or the Cairo compiler, I want you to generate traits for me. So as you can see, if you do this and you still run Cairo run, we're still going to get everything. We're going to get the area, and we're going to get the new width. So essentially what we're doing with generate traits macro, right, is we are telling the compiler, I want you to generate a trait for this implementation. So it's going to read through the implementation, right, and generate the trait, or basically the interface for like this particular implementation. Alright, so back again into our Cairo book, and so we already looked at generate traits, we already looked at how you can pass in stuff to your method by snapshots and references. Now you can also like of course pass in like multiple parameters, but we're just going to skip this because of time. And yeah, so the next thing we're going to look at is associated functions. Now basically what we call associated functions, right, is like all the methods, all the functions basically that are related or pertaining to like a particular structure, right, or whatever. So it's good practice most times to like group things, right? So for example, if you have like different methods that are related to a particular struct, you want to like group them under one particular implementation. It makes things easier to read, it's better organization. But of course, like the compiler will probably not shout at you if you don't do something like that, right? But it's just good practice to do that. And something else we probably forgot to mention, right, is thus far we've been using like the self property as the first argument, right, when instantiating a method. But you can actually use just a normal variable, right? And but when you do that, you can see how you call it. The way you call it will be different. So essentially what we've done with the array trait and so many more. So let's just hop back into like our VS Code editor and like play around with that. So let's create a new function. I don't know what we want to call this function, right? So let's assume we want it to actually instantiate a new rectangle. So what we want to get in it, right? So want the function to be responsible for instantiating a new rectangle. So we want you to pass in a width, which is going to be in 16, and a height, which is also going to be a UN16, right? And it's probably just going to return a rectangle to you. Okay, so what we want to do within the new function, right, is just simply instantiate a new rectangle where the width and the height is same, and that's all we need to do. Remember, shorthands. Okay, so how do we want to do this? Recall that this time around we didn't pass in the first argument as self, and when you don't pass in the first argument as self, essentially how you would probably want to use that function or that method in this case will now be let's say let new rectangle be equal to, we're going to do in this case let's see, rectangle new, and new is going to take in two values, so 10, 20. Okay, so invalid part, let's see, oh yeah, sorry, so we are actually like calling the new function within the rectangle implementation, and we're passing in the 10 and 20 value, which stands for the width and the height. So as you can see, we didn't use the dot notation because the first argument in this case is not like the self, so we can use dot notation here. All right, so and if you try to print that value once again, and the width is, so what we're going to get is, let's see what we're going to get, new rectangle dot width. So we expected to like get 10, so I'm going to clear since our terminal was getting a bit clunky, and scarp Cairo run. So you can see the new width is 10. So that's essentially how you can use like a function or a method whose first argument is not like a self variable. So let's hop into our Cairo book and check if there's anything missing. All right, so we just looked at this, and yeah, something else is you can always create multiple threads and implementations, right, for a particular struct. You are not restricted to just one trait and one implementation. You can create multiple ones, but first of all, be sure to ensure like it makes sense logically, because while the compiler might not shout, other persons might go through your code, so you want to be like as explicitly clear as possible. All right, so we are done with the method syntax. So now let's take our quiz. So question 1 says determine whether the program will pass the compiler. If it passes, write the expected output of the program. So we have a struct rectangle which was defined, then we have all these methods, an area method which basically does the calculation for the area, a new which instantiates a new rectangle, and compare areas which compares the areas of like two rectangles. Okay, so next up we have the main function. The main function creates two rectangles, rectangle 1 and rectangle 2, which was created in the new, and now we're checking to see if both of them are of equal areas. So rect1 dot compare areas means that the first argument this is going to take in will be rect1, and at rect2, so this is going to compile, but it's going to return false, since like the area will not be the same. The width of this and the width of this, the height of this and the height of this is not the same, so the area cannot be the same. So we're going to get returned an output of false. Okay, so the next question, determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So we instantiate a new struct. Okay, then we have the circle struct, then the rectangle traits. Okay, now we have an area, we calculate the area for the rectangle trait, and this is the implementation. And okay, we instantiate a rectangle here, then we instantiate a circle, then we're trying to get the area for the circle. Now this is going to fail, it's not going to compile because the area implementation we have is just for like the rectangle struct, so this is not going to compile. And let's submit. All right, and we got our two answers correctly. And yeah, so we've come to like the end of this particular chapter or episode on struct. And as always, if you have any questions, you can reach out to me on Twitter at Rex Darlington, on Telegram at Darlington68. If you enjoyed this particular episode, do like, subscribe, hit the notification bell so you are informed every time we drop a new video. And with that, I'll see you in the next one.